So previously we talked about reflection and the laws of reflection. We were talking about plane mirrors. So remember, plane mirrors are the mirrors that are flat, and so they work with the regular laws of reflection. And so I just put this guy in here so we can kind of refresh on that. So we've got our flat mirror here in the center, and we have our incoming light rays. So incoming for the arrow to point to it, and that is going to bounce back at the exact same angle, just in the opposite direction. And so here we've got the ray coming off the top of the guy's hat, little stick guy or gal, and hitting the mirror and bouncing back and hitting eyes. And then we've got the same thing happening down here at the feet, light rays hitting the feet, bouncing to the mirror, and then bouncing up to the eyes. What is kind of cool about this picture is it actually shows you what size mirror you need in order to see any object. And so basically it's roughly half the size of the object is required to see the entire object in the mirror. And that is because of the light rays. So you have the light rays bouncing to meet your eyes, and so in order to see those objects, so for example, if you want to be able to see yourself full length, you actually only need half of a mirror to do that, half your height. But remember, we're also looking at a virtual image of ourselves in the mirror, and that's because those light rays are for our brains extending backwards into the mirror the same distance that we're standing away from that mirror. So why am I talking about plane mirrors again? Well, I wanted to talk a little bit about some other things that you may run into that are not in your text. So curved mirrors. So curved mirrors are interesting because they do reflect, but they reflect differently than plane mirrors because of their curved surface. So you can see up here that the arrow diagrams are going to work a little differently. They do still work via like the law of reflection, but the light rays are going to converge differently because of that curved surface. So there are two types of curved mirrors. The first one is convex. So that is the one up here that's labeled A. And so these are any sort of mirror that's going to curve outwards. So they're the ones that look like kind of bubbled. So you've seen these before. You probably, you may have one on your vehicle, depending on the size of your vehicle. I know, for example, on campus, we have one or two of these in the parking lots, so you can see around corners. And the thing is because of how these work, the image is actually smaller and closer to the mirror than the object is. And so if you look up here, you can kind of see how that works. So the light rays come in and they reflect, and they're still working the same way, but when the bend occurs, those reflected light rays, when our brain draws the line, they don't draw the line as big as the object actually is. And that curve shrinks those light rays, shrinks that object. And so that's why in mirrors that are convex, which car mirrors generally are slightly convex, you see that little warning, objects may appear smaller than they actually are. When you have the little additional mirror like this, they definitely will appear smaller because these are more convex. But the advantage is it increases your field of view. So it shrinks everything, but it allows you to see a bigger area because everything is a little smaller. And so that's the big advantage of a convex mirror, is that it gives you a very wide field of view. And that's why they're commonly put on vehicles and used in things like driveways and parking lots, because even though the objects are small, it allows you to use those big fields of view. Like I said, I know we have at least one, if not two of these on campus so that you can see out and around where you normally wouldn't be able to see. The other one is a concave mirror. So these are caves, they bend inward. And these do the opposite with the light rays. So you can see those light rays still hit the mirror. So they come in and they hit the mirror and bounce off. But because of that curve, when they bounce back, they actually spread out when our eyes draw those imaginary lines, the virtual lines, backwards. And so you've seen these sorts of mirrors before. This is one that's mounted at a science center. And so these, because of that curve and spreading out those light rays, it's going to make objects appear larger. So it's going to create an enlarged virtual image behind that mirror. So what kinds of things do we use these mirrors for? We commonly see these in shaving mirrors and makeup mirrors, but we can also use them to do different types of effects. So you'll also see convex and concave mirrors if you've ever been, for example, in one of the fun houses at the circus or at a fair or festival, because they will combine these to make those strange and weird images, because they're expanding and contracting, your visions by altering the shape of the mirrors, either by curving them out with convex shapes or curving them in with concave shapes. There are also some optical illusions that are based on using convex and concave mirrors out there, so you can take a look and try and find some of those. The other thing that I wanted to talk about, because many of you work with cameras and so forth, are lenses, because lenses also work on the same sorts of principles as mirrors. So we're going to start first with concave lenses. So concave lenses are what we call diverging lenses. What this means is when the light rays come into the lens, you can see up here, we've got a parallel light ray coming into a concave lens. And when it goes into the lens, it gets bent. So with lenses, they're made out of transparent material. And if you remember in an earlier lecture, when we get light rays moving from one medium to another, so for example, air to something like glass or plastic, the speed of light changes. It slows down when it gets into that transparent material. And so when that light ray hits this concave lens, it's going to slow down, it's going to refract, it's going to bend. And with the way that this is shaped, it's going to bend out here to the left, or going upwards. And it's going to do it twice because of the bends in the lens. And so the reason why this is called, let me grab my pen here, a divergent lens, is if we get a bunch of these going into the lens, they're going to all diverge or spread away from each other. They don't come to a focus point on the other side of the concave lens here. So what good is a concave lens then if it's going to diverge all of the light? So concave lenses are used in vision correction and also can be combined with other lenses in order to focus light that's coming in. What's interesting with concave lenses is if you look through a double concave lens like this one, So if we had, for example, someone over here on this side, I'm not going to be very good at drawing an eyeball. Let's do and eye. There we go. So, so we've got somebody who's looking through this lens. So the object is actually over here on the opposite side of the lens. When the person looks into the lens towards that object, what happens because of this being a diverging lens, the actual light rays are going to appear to focus or converge here at this area. And so it's going to still appear to this individual that the object is on the opposite side of the lens, and it's going to be smaller. That's why it says down here it's diminished. It will be right side up, and that's important because we're going to take a look at the other type of lens here in a second. So it'll be smaller, it'll be right side up, closer to the lens, and it's going to be a virtual image. If you remember, we talked about virtual versus real image. So this is going to be a virtual image, meaning that it won't be able to be projected onto a screen or anything. It's not actually there because the light for that's actually creating the image, the light is actually over on the side with the observer. All right. So the more common lens that you come across is actually this guy, a convex lens. It sounds familiar, right, with the mirrors that we were just looking at. So convex lenses, tuck myself up out of the way. So convex lenses are the opposite. They are converging lenses. So when the incoming light hits a convex lens, in this case a double convex lens, so it's bent on both sides, the light, instead of diverging, spreading out, converges to a focal point, a single point, before it then diverges. And so this is why we use convex lenses, to be able to focus and make sharp images. Like I said, this is our most commonly used lens. So you're going to find them in things like magnifiers, cameras, eyeglasses, telescopes. I mean, all kinds of different pieces. Microscopes, I work on microscopes all the time, and this is the kind of lens that's mounted in a microscope. So how are these guys working? So here, this is the same sort of thing that's going on up here, just with a convex lens. So we've got the same sort of thing. We've got our object on this side, and we've got our observer on this side. All right. Now, with our observer on this side, our observer actually won't be able to see the image that the convex lens is making unless they're farther back. I can't really draw the eye all the way back, so imagine that they're farther back here. So we've got our object here. The light rays come off of the object, so they're traveling in this direction, all three that you see drawn in. Now, obviously, there are more light rays than this, but we don't want to make the diagram really crazy. So the light rays come into the convex lens, and just like the concave lens, because it's a different material, they refract, they bend, and they're going to bend depending on where they're hitting. So you can see that this one's going to refract a lot. The one here in the middle is actually going to travel straight because it's not going to refract at all, just because of the angle that it's hitting at. And the green one is going to refract opposite of the red one because of the angle that it's hitting at. And so they're all going to converge over here on this point, on the opposite side. So we're focusing on the tip of the arrow in this case. Now this is actually happening all along the object. Same thing up here. They're only just showing you the tip. But this is happening all along the object. And what we have happen is the object on this side of the lens is right side up. On the opposite side of the convex lens, the opposite, or the arrow is now upside down. And so what happens with the convex lens is that it actually flips the image. It does make the image, though, real. So you could put a screen over here and view the image. This is actually how projectors work. So projectors are another place that you'd find convex lenses. And so you do have a real image because this is where the light is. The light has traveled through the lens and appeared on the other side. There is the small problem that your image is upside down, but there are ways to fix that. So then the question is, well, that's not how a magnifying glass works, because if we look here, the object is this size and it's obvious on this size it's bigger, and that's actually what we want when we have something like a projector. So how does a magnifier work? Well, if we look here, we've actually put the object behind the focal point, right? Not closer to the lens, between the focal point and the lens. The focal point is the area where you've got the convergence here. So we're going to put the object behind the focal point. That will make the object bigger. Well, if we want to magnify the object, what you end up doing is you put the object close to the lens, so between the focal point and the object. What that does is it creates a larger image on this side of the, erase this, on this side of the lens, so that you can see the observer is on the opposite side of the lens. The light is going through the convex lens, but just like with the mirror, the light is going through and hitting the eye of the observer. And what it's doing is our brains are converging those light rays behind the lens and creating a virtual image that is bigger. So this is how we use convex lenses to magnify things. We're actually creating a virtual image, so you can't put a screen back here and get an image to show up. So when we use convex lenses to magnify things, we're creating a virtual image because our eyes are extending those light rays that are actually traveling through the lenses and making it to our eyes. All right, so that is mirrors and lenses, and that's all I've got to say on them.